We just discussed about how a particular vector can be resolved, correct? Now let's try to understand what if we have two vectors or 2 points. Assume that there are 2 points and distance between the 2 points in the vectorial form. Okay, in terms of vectors, we'll try to calculate the distance between the 2 points. Now, all of you remember position vector, correct? Where the point is situated, we take from origin to that particular point, we calculate the distance. That is basically the position vector. Now, in this, let's say we are going to have the x and y axis. So, assume that you have the x and y axis, just two dimension. Now, here, say there are 2 points here. Okay, let's say this point is A, say this point is B. Okay, and we are trying to calculate the distance from point A to point B. Okay, now first thing what we are going to do, it's very easy. First we write the position vector of point A. That means here, let's say OA, vector OA is equal to A and OB is equal to B. This is the position vector. That means here we can write that O to A, this is one vector, O to B is one more vector. So we have two vectors, right? Now what we need is AB vector, correct? AB. Now what we'll do, we'll write vector A is equal to, so here we have AX I cap plus AY j cap, correct? And vector B will be BX I cap plus BY j cap, isn't it? Now, since we are looking only in 2 dimension, we have just I and j. Now, if you extend the same thing into 3 dimension, then we are also going to have plus AZ k cap plus BZ k cap, correct? If you extend it into 3 dimension. Now, here you have vector A, vector B in terms of its components x, y, and z, or you can say in terms of I, j, and k. The next thing what we have is, let's try to find what is AB distance. See, what we are looking at is, we are looking at this one, AB, correct? Now we'll use the triangle law of addition. See, in triangle law or from triangle law of addition, what we can write, vector OA plus AB is equal to OB, correct? So what is AB vector then? AB vector becomes OB minus OA. OB minus OA. That means if we do the same thing using the components, because components is what we have for a vector, isn't it? So if you do it with the components, OB minus OA, that means AB, in this case, AB is equal to vector B minus vector A, because that's OB minus OA. But what is B? B is given by this. Now, remember one thing, whenever we have components, the I components can be added or subtracted with I. In the sense, only these two can be added or subtracted. You can't add the I component with the K component. And it's quite obvious, because x-axis component has to be multiplied by, not just multiplied, added by, subtracted by. All these things has to be done by an I component itself. And we can't do it with K or Y or whatever it is. Fine. So in this case, what we have, B minus A. So AB vector AB is equal to BX minus AX into I cap, first one, plus BY minus AY into J cap, plus BZ minus AZ into K cap. So this basically, whatever we just saw, this one, this basically is the distance between the 2 points, or you can also say it is the length of the vector between the 2 points. Now, when you say length, I'm not talking about the magnitude, I'm talking about the vector itself. Fine. If you need the magnitude, then what do? We do root of square of this one plus square of this plus square of this. Like how we did root of ax square plus ay square plus az square. Same way we do this one. Now, see, once you have done this particular, distance between the 2 points in the vector form, what we have to understand is that certain properties of the components of vectors. Here we subtracted only the I components, only the j, only the k components, correct? Now, similarly, suppose if you have two vectors, what components can be added or subtracted, or what if you multiply by a constant? So we'll look into these properties now, okay? But remember, everything is based on, because we did the subtraction here, it's just a recap of whatever those properties are, okay? Let's assume that you have vector A is equal to ax I cap plus ay j cap plus az k cap. This is one vector. Say vector B is equal to bx I cap plus by j cap plus bz k cap. Suppose if you do A plus B, remember only I can be added. So that means this becomes ax plus bx into I cap plus ay plus by into j cap plus az plus bz into k cap. Correct? What if we have minus? Then minus, minus, minus. Plus or minus, plus or minus, plus or minus. Clear? This is the second part is what we just did right now. Now, what if we multiply by a constant? In the sense, what if we write some value lambda into vector A? That lambda gets multiplied to all the components. That is lambda into ax, I cap, lambda into ay, j cap, plus lambda into az, k cap. The lambda value gets multiplied to each and every component of the vector. Clear? So whenever we look into the components and whenever we look into the distance between the 2 points in a space, this is how you have to imagine how do we get the distance. Now I'll show you one quick example. Okay, very quick example. Suppose let's assume that one point is say 2 comma 0 comma 1, okay, and point B is say 3 comma minus 1 comma 2. What is the what is vector AB? Suppose if I ask you this vector AB, then I'll also ask you what is the distance between point A and point B. Remember, AB is what? OB minus OA, right? So AB vector is OB minus OA. So what is OB minus OA? Now we are going to take the x component, subtract 3 minus 2 into I cap plus minus 1 minus 0 minus 1 minus 0 into j cap plus 2 minus 1 2 minus 1 into k cap. So what do we get? I minus j plus k. So what is mod of AB now? So mod AB becomes root of 1 square plus 1 square plus 1 square, which is root 3. See, this is how we find the distance as well as the vector. Okay, this is what we mean by distance between the 2 points. Clear? So we'll try to solve few problems based on whatever the concepts we have learned so far. Based on those things, we'll look into the next chapters and next components later. Based on that, we'll look into the next topics later.